we have F1 as a vector equal positive 20 I 0 J 0 K. F2 as a vector equal 0 I positive 10 J positive 0 K. F3 as a vector equal 0 I 0 J and positive 10 K. The last force P, which is given, I give you a hint. Assume B as a vector, BXI, PYJ, BZK. Do you have any more forces? No. All of these forces are in equilibrium. That means X component plus X component plus X component plus X component equals 0. So we have 20 plus 0 plus 0 plus PX, all of them equal 0. That means BX equal negative 20. Summation of all Y component equals 0. So we have 0 plus 10 plus 0 plus PY equals 0. That means PY will be negative 10. Summation of all Z components equals 0. So we have 0 plus 10 plus PZ equals 0. So PZ will be negative 10. That means your final force P will be negative 20 I, negative 10 J, and negative 10 K. Do you have this answer in A or B or C? No, we don't have these answers. For the first one, this one is positive, but the actual answer is negative. For the second one, this one is negative 10, but this one is negative 20. The third one, this one is positive, but we are looking for negative. So none of them. We need to do some calculations. I told you, guys, try to do some calculations. Don't try to say A, B, C, D. That's it. From the first question, I can answer the second question. If you have a force like P, we don't have anything about P. We don't have the value. We don't have alpha, beta, gamma. We don't have anything. How can I assume this force? Your force as a vector can be assumed like Fxi, Fyj, and Fzk. So how many unknowns do you have in your assumption? 3. Probably, I can accept your answer if you say F as a vector equal F cosine alpha, I, F cosine beta, J, F cosine gamma, K. So we have alpha, beta, gamma, and F. So I can accept 4, probably. But I'm looking for minimum. So the minimum number will be 3. But if you select 4, I graded it correct. But 1 or 2 is wrong. No way. 1 or 2, wrong. The last one, I told you if we have a system of fluids in equilibrium, that means summation of all X component equals 0, summation of all Y component equals 0, summation of all Z component equals 0. That means your resultant force as a vector will be 0I, 0J, and 0K. If your forces are in equilibrium, that means summation of all X component equals 0, summation of all Y component equals 0, summation of all Z component equals 0. That means your resultant looks like this. So which answer? Number B. Any question? Any question for this exam? I'm sorry, for this quiz? Very easy. Very easy. But I didn't expect most of the students get 7 from 10. Most of them. And probably we have 5 also from 10. Any question? Okay. Let's start our topic today. Last meeting, I talked about a rigid body in equilibrium. And this rigid body in 2D. That means you are talking about X and Y only. Everything in the plane of the screen. So remember, if you have a particle, only 1 point, 1 joint, 1 particle in equilibrium in 2D, we have 2 equilibrium equations. Summation of all X components, summation of all Y components, horizontal and vertical components. If this particle, 1 point or 1 joint or 1 particle in 3D, so we have summation of all X component equals 0, all Y component equals 0, all Z component equals 0. But right now we are talking about body, and this body is rigid. So we are talking about structure. Your structure probably can be a beam or a frame or truss. And last time I told you what is the difference between beam, frame, and truss. In this course, it's not a big deal to figure out what is the meaning of this structure, because all of this stuff will be discussed in more details in another course called Structure Analysis and Design course. Anyway, your structure, whatever, beam or frame or truss, will be supported by different type of supports. We discussed the different type of supports last time. We have a fixed support, we have hinge or pin support, we have roller support. If your support is fixed, so we have 3 reactions. If your support is hinge or pin, we have 2 reactions. If your support is roller, we have 1 reaction. This reaction is perpendicular to the base of the roller. Guys, I would like to remind you for something. If you have fixed support like this, how many reactions? 3. 1 vertical force, 1 vertical reaction as a force, 1 horizontal reaction as a force, and 1 moment. My question is, how can I assume these reactions? You can assume what you want. I'm sorry, what you mean? If you assume this reaction up, that's right. If you assume it down, that's right. It's up to you. But we have vertical reaction. If you assume the horizontal reaction like this, that's right. If you assume horizontal reaction in this direction, that's right. It's up to you. If you assume this moment rotate counterclockwise, that's right. If you assume this moment to rotate clockwise, that's right. So you can assume any directions for the reactions as you like. But remember, we must have vertical reaction, horizontal reaction, and moment. The same, if we have pin support like this, do you remember how many reactions? 2. 1 vertical and 1 horizontal. We have 1 vertical and 1 horizontal. You can assume the vertical one like this, the horizontal one like this, or the vertical one like this and the horizontal one like this, or the vertical one is down and the horizontal one like this. It's up to you. You can assume any direction, right or left, up or down. But remember, you have to keep the number of reactions, 2, 1 vertical and 1 horizontal. Any question for this point? If you have any question at any time, let me know. Okay, if you have a rigid body and this rigid body in equilibrium, we have 3 different equilibrium equations. 3 also. but different a little bit. The first one, summation of all forces in X equals 0. Summation of all forces in Y equals 0. And we have a third equation of equilibrium called summation moment at any point equals 0. And I told you last time, moment means you multiply force times distance. If you have a force and you have distance and you multiply it, both of them together, you will get a moment. But we have one condition. Keep it in your mind all the time. The force and the distance must be perpendicular. Doesn't make any sense to have a force like this and you have a distance like this. This one is 5 feet. This force is 50 kb. And you are saying the moment equal 50 times times 5. Because you will say, hey, the instructor said force times distance. But this force and this distance are not perpendicular. What you did is wrong. Your force and your distance must be perpendicular. We stopped here last time, so I'm gonna continue. We have different type of fluids. Probably in any structure, beam, frame, or truss, probably you can find something like this. This shape called concentrated moment. Concentrated moment, and this moment can rotate counter or clockwise. Sometimes you will find something like this, concentrated load. It's a force. This one is a force, but at one point only. So it's called concentrated force or load. We have something new today, which called distributed load. Which called distributed load. This distributed load is uniform distribution over the beam length with a value here W, and this W can be kilonewton per meter or Newton per meter or pound per foot or kb per foot, whatever. But what I mean, force per length. The unit for this W will be force unit per length unit. Just to remind you, if you have a force which is inclined, we don't like inclined force. All the time your force must be horizontal or vertical. So if you have a force inclined, we need to figure out the horizontal and vertical component. And you remember that in the first week. If you have a force and you have a given angle theta, the component be adjacent to the given angle will be cosine. So this one will be F cosine and the other one will be F sine. Sometimes I will give you a force without angle, but I will give you a right angle triangle. So you can select this angle, for example, and this angle will equal to this one. So I can say this one is theta, so this component will be F cosine theta, and this one will be F sine theta. Sine theta and the cosine theta can be figured out from this triangle, because this one is 4, 3, and this one will be 5. Any question? So today I started with, sometimes we have different type of fluids. Different types of fluids. Probably your fluid may be concentrated moment, maybe concentrated force, maybe distributed fluid. And sometimes your force is inclined. We don't like inclined forces. We like forces to be horizontal or vertical. Why? Anybody know why? Why we are looking to make each force to be horizontal or vertical only? Do you know why? Okay, Mitchell. Mitchell, you have extra 3 points for the coming exam. John Miller, no, we will not figure out the resultant force. Guys, I told you we have 2 equilibrium equations. We need to apply the first equilibrium equation, which is summation of all forces in x direction equals 0. And summation of all forces in y direction equals 0. So I'm looking to make all forces in any problem to be horizontal and vertical. Why horizontal? To say all horizontal forces, summation of all horizontal forces equals 0. And to say summation of all vertical forces equals 0. Today, we will apply a new equilibrium equation, summation moment at any point equal 0. Okay? So let's try to do this first example. We can expect something like this in the exam, the 5th question. And the problem like this, or in this topic, will ask for something called calculate reactions. For the shown beam, this structure called beam, we don't care. And this structure is supported at A with a roller. So at A, it's a roller. And B, at B, is supported by a hinge. So if you go back to, if you have a roller support, how many reactions do you have? Only one. Which direction? Vertical or horizontal or what? Perpendicular to the base of the roller. So we have reaction here, vertical reaction YA. I'm sorry, why you label this reaction by YA? Because this reaction in Y direction, so I labeled it with Y. And this reaction at point called A, so I labeled this reaction YA. The second support, which is B, what type of support do you have? We have hinge support. If you go back, if you have a hinge support, how many reactions do you expect? I expect 2 reactions, one vertical and one horizontal. So I'm gonna assume vertical reaction and horizontal reaction. Can you tell me which direction I'm gonna assume? As you like. As you like. I will assume this one vertically up and this one in this direction. It's up to you. But remember, the vertical reaction, I'm gonna label it by YB. The horizontal reaction, I'm gonna assume it XB. So guys, your label for reactions can be done like this. The first one, which direction? If you are talking about horizontal reaction, so I'm gonna assume it X. If you are talking about vertical reaction, I'm gonna assume it Y. Then at what point, if you are talking about point A, so this one will be YA or XA. So did you understand how we can label the reaction? So please, first step, you need to figure out how many reactions you have. What's your reaction? Then you can label it. If your reaction in vertical direction, so I'm gonna label it Y. And then YA, because you are talking about point A. If your reaction in X direction, I'm gonna label it X. B, because you are talking about point B. Any question so far? Any question? It's very easy. This problem, I believe, the most easy problem in your coming exam. So, next step. Apply apply equilibrium equation. By the way, do you have any inclined force in this problem? Do you have any inclined force? I don't think so. We have 500 vertical, 200 vertical, 300 vertical. We have these reactions vertical and horizontal. We don't have anything inclined. Second question, do you have any distributed load? Because distributed load must be adjusted first before starting. No, we don't have. We don't have. So after you put your reaction, you need to ask yourself two questions only, two questions, and then go forward. The first question, do you have any inclined force? No. If yes, if you have, go ahead and get the components, the horizontal and vertical component. Okay. Second question, do you have any distributed load? No. So go forward. If yes, I will discuss it later, just a few minutes later. Okay. So we are done. These questions, no. Then go forward to apply this equilibrium equation. Summation of all horizontal forces, summation of all x forces equals 0. Please tell me what forces in this problem in x direction. Don't forget any. Don't forget any. Please look to the problem and tell me what are the forces in x direction. I believe we have positive xb. Anything else? Are you sure? I'm sure. Nothing else. Okay. Positive xb equals 0. That means the reaction xb is 0. Keep going. Summation of all y forces equals 0. All forces in y direction, summation of all these forces equals 0. So we have positive YA. We have negative 500. We have negative 200. We have positive YB. We have negative 300. Anything else? Are you sure? Nothing else. All of this stuff equals 0. Can you simplify this equation a little bit? Yeah. I will keep YA, which is positive, and YB, which is positive, in this side. And I'm going to move everything else to the other side. We have 500, 200, 300 will be 1000 and will be positive. Hey, these numbers in negative sign, negative, negative, negative. Yeah, I know, but you moved them to the other side. So if you move them to the other side, will be positive. How many equations, how many unknowns do you have in this equation? Two unknowns, YA and YB. I cannot do anything more. So please label it as equation number 1. Any questions so far? B shell, where is XA? Do you have anything at A in X? Do you remember the first step in the problem? You need to put your reaction. Do you have horizontal reaction at the roller at A? Guys, be careful about this point. First step, you need to put your reaction, and please put your reaction correctly. For roller support, we have only one reaction perpendicular to this base. So we have vertical reaction only, nothing else. For B, it's a hinge. So we have two reactions, one vertical and one horizontal. So by the end, if you apply summation f of x equals 0, we have only xb. Okay. Okay. So we applied, how many equations do you apply? We applied only 2. Summation f of x, summation f of y. We still have one more. We still have one more. Summation moment. Let me write this equation here. This equation can be called summation moment at any point equals 0. Summation moment at any point equals 0. Before going on in this problem, I have a question. If you have a force here, 10 kib, and we have another force here, 20 kib, and we have another force here, 15 kib, and we have a point here called A. And this distance equal 5 feet, and this distance equal 8 feet. If I apply summation moment at A equals 0, I'm sorry, if I'm looking for summation of moment at A, do you remember moment equal what? Force time distance. And your force and your distance must be perpendicular. Let's start. This point is very important, critical. Please pay attention. Let's start. You are sit down at point A. So we are here at this point A all the time. All the time we are at this point because you're taking a moment at A. First force, do you have 15? So 15. Here is the force. We need distance, time distance. What is the distance between, and the distance must be perpendicular to the force. What is the perpendicular distance between this force, which is 15, and this point, which is A? What is the distance which is perpendicular? So your force is vertical, so your distance must be horizontal. Any answer? What is the horizontal distance between force 15 and your point A? What is the horizontal distance? Thank you, John. Yes, it's 0. Mitchell, I am sit down at point A because you are taking a moment at A. And I'm talking about 15. My question is, what is the horizontal distance between force 15 and point A? 0. We don't have distance because 15 at the same location for point A. So 0. Why not? 0 is a number. Keep going. Second force, you are talking about 20. So we have a force here, 20. What is the distance between this force, 20, and the point A that you are sit down there? Do you have a distance between this force and this point? I think yes, we have 5. Be careful and be sure that this distance and this force are perpendicular. Keep going. The next force is 10 kib. The question is, what is the distance? What is the distance between this force, which is 10, and this point, which is A? What is the distance between this force and this point? It's 13. 8 plus 5. Be sure that the distance and the force are perpendicular. You can get the final answer because I don't have any forces more. So, force time distance equal moment. Sometimes you have a force, but we don't have distance because your distance is 0, like 15 and the point A. Remember, all the time we are sitting at A. We are sitting at A all the time. So every distance is measured from point A and each force. Let me repeat this one more time. Thank you, Anton. In this problem. Next equilibrium equation, I'm gonna take moment at any point. So I will take moment at A, at this point, moment at A, equal 0. But before also doing this, I have another thing I need to discuss first. If you have a point and you have a force like this, or you have a point and you have a force like this, if you multiply this force by this distance, you can get a moment. Can you tell me what is the direction of this moment? I think if you assume this point looks like square, and you are driving your car in this direction and you would like to rotate around this center point, I believe you will rotate like this, which is clockwise. That's right. If you are driving the car in this direction and you would like to rotate around this probably fountain or something, I believe this force will be multiplied by this distance and will rotate in this direction, which is counter clockwise. That's right. That's right. Any question? Yeah. So probably your force can rotate clockwise or your force can rotate counterclockwise. If you are taking a moment at A, so all the time I'm sitting at A. The third equilibrium equation, summation moment at any point equals 0. So I select point A. So summation moment at A equals 0. Let's start one by one. We are sitting at A. What forces do you have? We have YA. First force. Can you tell me what is the distance between force A and the point A? Do you have distance in between? I don't think so. We have 0. Keep going. We have 500. And this 500 has a distance between 500 and the point A, how much? 8 feet. and this force rotating clockwise. I'm gonna assume it positive. So I'm assuming positive direction is the clockwise direction. Keep going. Keep going. What do you have else? What is the next force? The next force is 200. We have 200. What is the distance between 200 and point A that you selected? What is the distance in between? 16. I believe this car would like to rotate clockwise around point A. So it's positive also, because I assume this direction is positive. Keep going, but remember, at point B, we have vertical reaction YB. What is the distance between YB and point A? What is the distance? 16. But this direction is negative. Why? Because YB going up to multiply by 16 will rotate counterclockwise, I believe. So it's opposite to your assumption, so it will be negative. What else? What do you have else? At the same point B, we have XB. So plus XB time what distance? Let me ask you a question. What is the distance between XB and point A? What is the distance between XB at this point B and point A? Any answer? This distance is 0. Guys, we have a point A, and here at point B, we have a force here called XB. And I'm asking the distance between XB and the point A, and this distance is 0. Yes, I'm right. Why? Because your force is horizontal force. If you are looking for moment, your force and your distance must be perpendicular. So right now, your force is horizontal. So your distance must be vertical to make this perpendicular shape. So the question must be like this. What is the vertical distance between this force and this point? Do you have any vertical distance between this location and this location? Actually, we don't have vertical distance because both of them at the same line. So your vertical distance equals 0. Guys, remember, your force and your distance must be perpendicular. Your force and your distance must be perpendicular. In this case, 500 is vertical. Your distance is horizontal. In this case, 200 is vertical. Your distance 16 is horizontal. In this case, YB is vertical. Your distance 16 is horizontal. In this case, XB is horizontal. Your distance must be vertical. Do you have vertical distance between this point and this point? We don't have. We don't have distance. You got it? We still have one more. Please don't forget any. Plus 300. Why plus? It will rotate clockwise like this. How much the distance? This force is a vertical force, so your distance must be horizontal. How much? The total distance between this force and point A is 24. Don't forget any. I am done with all of them. This summation equals 0. I believe this term will be cancelled because ya times 0 is 0. And this term will be cancelled. Xb times 0 is 0. The only unknown in this equation will be yb. So my reaction yb will be your reaction yb equal positive 900. So reaction from this equation for yb equal 900. If you go back to this equation that you set up before, yb right now is known 900. Can I figure out the value of ya? Yes, you can. So this one is 900. By this equation, this one will be 100. From the first one, you get xb equal 0. I am done with my reaction because the problem asked to calculate reaction. From the beginning, we have 3 reactions, ya, yb, and xb, and I can get these values right now. For a Chromium equation, summation f of x equals 0 is nothing. Very easy. Summation f of y equals 0 is nothing. Very easy. Summation moment, you need to be careful about this equation a little bit. And we will do more examples next time regarding this point.